Hey guys, welcome to this new video on the OKP4 protocol architecture. If you haven't seen the previous video, I invite you to check it out here. The last time we described the protocol through a high-level overview of the architecture composed by three main domains. And today we're gonna go deeper by exploring the low part of the architecture with practical and concrete examples. To remind you, the low domain responsibility is tied to the rules we can design for zone governance and digital resources consent rules. So let's get started. Okay, let's start by giving some specification about the low part of the architecture. So first we will have the rules expressiveness, because when you write governance and digital resources consent rules, you need to be able to express anything as a rule, and for that we will need a proper language. Second, the querying capabilities. We will need to be able to evaluate the rules given a certain context. To enhance the possibilities, we need to bring some context to the rules execution by interoperate with the other components of the chain, like all the on-chain data carried by all the Cosmos modules. And finally, as governance and digital resource consent relies upon rules, we need to ensure they are stable and available at all time. To meet those criteria, I'll introduce to you some architecture components, and today we are going to talk about the logic module, also the object-oriented smart contract, and finally the lost-on smart contract. First, I would like to introduce to you Prolog, which is a programming language created in the 70s. This programming language, how it works, basically you feed a knowledge database with rules and facts, and then you are able to query this knowledge database. And this is the choice we made to design the rules, and so all the rules in the OKP4 protocol will be written in Prolog. So I will give you some example about Prolog, but we won't enter into some deep details about Prolog, just enough so you can understand why we made this choice. So here you have a little program with three predicates. The studies predicates, which indicate for a student the subject studied. So we can see some facts. Basically, Amelia studied history and Jack studied history also. We have the teaches predicates, which here indicates that William teaches history and Lily teaches math. And then we have a professor predicate, which is a rules based on the other predicates. So typically with these rules, given a professor and a student, the rule will be true if the professor is teaching a subject which is studied by the student. And now with this program, we can make some query. So typically we can ask using the professor predicate, giving William and Amelia as parameter, and the result will be true because William teaches history and Amelia studies history. We can go a little further by using some substitution mechanism. For example, if I still use the professor predicates with Lily as professor, and for the student argument I will pass a x variable, then the querying mechanism will substitute the x variable with the possible values given the knowledge database, which are Jack and Violet. This is a pretty simple example, but I think it can explain why we choose Prolog, and I hope you understand it. Okay, so now that we've talked about Prolog, I can introduce you the logic module. So for your information, the logic module has been designed as any other Cosmos SDK modules, and it is not strongly coupled with the OKP4 blockchain, so you can use it in your blockchain. The wiring of the app is pretty simple, but basically this logic module will contain a Prolog interpreter, and inside this Prolog interpreter we are able to create some custom predicates written in Go to allow us to integrate the other modules and on-chain data to be used as the context in the Prolog interpreter for the rules. There is also in Prolog predicates that allow to manipulate some file system elements. So we built a virtual file system bridge that will allow us to integrate some on-chain data as a file in the virtual file system, like smart contracts. And finally, regarding the gRPC API of the logic module, there is only a single ask query. There is no mutation, so there is no transaction messages associated with this module. Okay, let's move on to practice. So for that, I will use the OKP4D binary you can find on GitHub. We will provide to you the link to in the description. So I will work in a local environment, so I have the chain running locally, and typically you will make some command like OKP4D query logic ask, and then you can provide a query to be executed by the interpreter, and you can also provide, if you need, some context with a program as argument. So for example, I can provide a program which tells that Yuki is a star and query it. If I query if Yuki is a star, the response will be true. You can find in the response that you have the answer object with some elements and also some context linked to the execution with the gas that were used to execute the evaluation of the query, the height at which it were evaluated also. And for example, I can also use the substitution mechanism, and if I ask star x, I will have the possible substitution for x, which is Yuki, and I can also ask if Bernard is a star, and this is false, obviously. But as I said earlier, we can also implement some custom predicates to interact with on-chain context. And we've already implemented some. So for example, we can ask for the chain ID with the chain ID predicate, which will return OKP4 localnet, which is the localnet I'm running on my computer. And there is also some integration with the bank modules. For example, we can ask for bank balances. If I give an address, we can have the balance in for that address. And we will try to create a little program with that. For example, we will create the no balance, which will return the amount balance linked to the denomination. So the no balance will take as term the address and the amount, and it will unify those terms using the bank balances predicate. And now if I use it, we can extract only the amount linked to the denom, and just for the example, I will put that in a file. Let's call it bank no balance.pl, and we can use the program file argument instead on the command line. Okay. Okay, so now let's go a little further with the possibility offered by the logic module virtual file system. We just saw that we can provide a program to the logic module through the program argument of the ask query, but we can also in Prolog load source file using the consult predicate, which is built on top of the file system. And with this, you can provide a URI, which will be resolved by our virtual file system. And currently, you can use a custom WASM URI with this form to load data from a custom WASM smart contract. And so with that mechanism, you can load Prolog program from a smart contract query. And in this URI, you can find the contract name, which is only for descriptive purpose. There is the smart contract address, which we want to query, and the query message, URL encoded, and that's all. With this URI, we can make a good transition to the object-oriented smart contract. So this smart contract is an object storage, which allows us to store anything inside, anything as an object. And we have some specific features like the pinning mechanism that allow us to pin an object, which means that the object cannot be removed. And we will use mainly this object-oriented smart contract to store Prolog programs inside the protocol. And so with that, and using the consult predicate to load programs from the object-oriented inside the logic module into the Prolog interpreter, it allows us to create composable and reusable programs. And with the pinning mechanism, we can ensure that all the objects needed for the programs are available at all time. Okay, so let's give a little practical example on that objectarium. So I have a running chain locally, and the smart contract code is already stored in the chain. So I will now instantiate the smart contract with the WASM transaction for that. Okay, I just will change the label. So for that, I'll just give some parameters for the instantiate message. So I will give a bucket name, some limits, config, and pagination. We can omit them and it will use the default values. So let's launch the transaction and we will fetch the contract address. Here it is. Okay, so now that we have our object-oriented instance, we can store some object on it. So for that, we will use the already existing nobalance.pl program. So for that, here is the command line. We will use a WASM execute message, providing the smart contract address and the following JSON message with the nobalance file as base64 encoded. So if we launch the transaction, we can get in the event of the transaction the ID of the object, which is only a hash. And using that, we will be able to query it. So for example, providing the contract address. I can ask providing the object ID, the information about the object. Yep. So we can see that I am the owner. This is not pinned. We have the size, some information. And we can also retrieve the data associated with that object. And if we decode the base 64, this is our file. Okay, so now that we have stored a Prolog program inside the Objectarium, we will use the logic module to load this program and execute it. So for that we will make a logic ask query providing a program, and inside this program we will use the consult predicate. And if you remember well, in this consult predicate we need to mention a URI that will target the object inside the Objectarium through the corresponding custom WASM query. So here is the URI. I can give here a descriptive element. Let's just say the Objectarium. Now the smart contract address. And finally the query message URL encoded. And with that, just a query that will use the no balance predicate just missed the command, and now that's working. We can see the substitutions of the x variable with the amount of associated with this address. Okay, so finally we will talk about the low-stone smart contract, because as you can see with the Objectarium, this is kind of difficult to upload a lot of Prolog programs and to pin them. So the low-stone will be responsible to define all the rules, so it will carry all the links to the different objects in the Objectarium. So the low-stone define the rules, it allows to question the rules, so it will serve as intermediary to question the logic module. But this is not its responsibility to ensure that the rules are applied. And the stone part of the name has a meaning, because the low-stone, with the low-stone, the rules cannot be changed. The only thing we can do with the low-stone is to break the stone, to release all the objects. So the purpose is to guarantee the rules availability and stability through this smart contract. So for that, when you instantiate the low-stone smart contract, you give it a Prolog program, the main Prolog program, and the low-stone will query the logic module with this program to find out all the objects that are referenced in the Objectarium. So it will be able to pin them to prevent them from being removed. The low-stone smart contract is also the only entry point to the law. This means that this is the only element you can query to query the rules. And when you break the stone, it will release all the objects that are present in the Objectarium so they can be removed. Okay, so now to see the big picture, we can sum up the architecture of the low domain inside the protocol with those three elements: the logic module, the objectarium, and the lowstone. So the lowstone, as we said, is the entry point. It will use the objectarium to store and pin the prolog sources, and it will use the logic module to query the rules, and the logic module will fetch and load all the program sources through the objectarium using the custom WASM URI. Okay, so now we will see in details the different interaction you can have between the different components of the low architecture, so the lowstone, the objectarium, and the logic module. So we will consider the lowstone as the only entry point. So first we will instantiate it, and to instantiate it we will give it the main prolog program containing the rules and an admin address. The admin address will be the only one allowed to break the stone. We can consider that the rules.pl will rely on another prolog program, which is the util.pl, which is already stored on the objectarium. So in this scenario, we expect the lowstone to pin the util.pl. We will see how it will achieve that. So in the next step, the lowstone will store and pin the rules.pl on the objectarium and keep a reference to it. It will use this reference to load it inside the logic module and query it for the files that are used as source. So the logic module will load both the rules.pl and the util.pl files, and then will return as a result to the lowstone that the util.pl file is used inside the main program, and so the lowstone will then react to it and pin the util object on the objectarium to prevent it from being removed. This is how we achieved the entire stability and availability of the rules inside the protocol. And now to query the rules, you can make a query to the lowstone, and the lowstone will just forward the query to the logic module, which will load the programs, execute the query, and then return back the result. Okay, so now that we've seen all the details about the low architecture of the protocol, I propose to give some practical example to manipulate the lowstone. We will use two prolog files, the template and the gov. The governance will configure some elements of the template, and in the template we can find the main predicate, which is can, and can will allow some action to an identifier, a DID, given a certain some context. Among the actions we will find the change governance action, create service, create dataset, and execute workflow. And each of them have some condition. And for the create service, dataset, and workflow, the conditions are mainly based on balance, which is based on spendable coins. So the governance prolog main file will define the amount needed to allow these actions. This is only as sample purpose, so don't use that for a real governance, but it will show you how we can design some rules using some templates and relying on on-chain data. Okay, so first we need to upload the template, the prolog template for the governance in the objectarium. So for that we will just use the previous command we've seen earlier. Okay, we'll just check that everything's okay. So the transactions is okay, successful, and we have the objects hash here. So now we can instantiate the Lowstone smart contract. And to instantiate the Lowstone smart contract, we will provide as input the gov.pl file in base 64 encoded, and then the Lowstone will be responsible to store it on the Objectarium. And to make the Lowstone, to allow the Lowstone to store it on the Objectarium, we will give the Objectarium address also. So let's try this transaction, and we will get so in the event we will be able to get the Lowstone smart contract address, and we will use it to query it, and it will be responsible to call the logic module, and the logic module to load the program from the Objectarium, and we will make some interaction with this governance. So let's query it and ask it if the provided address can change the governance. This is the action we've seen earlier in the template. And the response is true because this is the address that is configured in the governance. If we change this address, it might be not a success, which is expected. Okay. And now we will try another query, one which rely on spendable coins on the bank module. So there is an interaction with the bank module in the chain. So with that address, it doesn't work because this address may not have enough spendable coins, and it works with this address, which has a sufficient balance. Okay, so that's the end of this example with the Lowstone smart contract. This concludes this video on the low part of the architecture. So if you need some help or have some questions, don't hesitate to reach out to me or any team member on Discord. We will provide you the invitation link to Discord in the description, and see you soon for the next video. We will be talking about the ontology.